So today we're just going to look at this idea of arcs of a circle and sectors of a circle. We know, of course, circumference is 2 pi r, and the area is pi r squared. These are things we know. And that's great if it's a complete circle. But let's say we just want a piece of the circle. So I've just created what we call an arc. AB is the arc. Now, if I want to find the length of that arc, we're basically saying I just want a piece of the circumference. So to work out the ratio, we look at the angle that's subtended at the centre. So it'll be theta out of the 2 pi radians. Right, so it's important that we use radians for this formula to work. And why do we use radians? Well, because look what happens very nicely. The 2 pi cancels with the 2 pi, and we get a lovely little formula. Length of the arc is simply radius times that angle. But again, that angle has to be measured in radians for the formula to work. Right, so length of an arc, L equals r theta. Now, the actual piece of the pie, if you like, is a sector. So a sector's boundary is the arc and the 2 radii. And if we want to find the area of that, we can do a similar thing. We'll say, well, it's that ratio of the area formula. Again, the pi's cancel nicely, and we get half r squared theta. So there's our area formula. All right, let's do an example. There's a circle, but you'll notice the angle they've given us is exactly in degrees. So we're going to have to convert that. So when we use our formula r times theta, we don't go 5 times 45. That would be incorrect. But 5 times pi on 4. So we have 5 pi on 4 centimetres. And if I want to find the area, half r squared theta, and what do we end up with there? 25 pi on 8 centimetres squared. The other common shape in a circle is the segment. And the segment is when we draw the chord in and it cuts the circle into 2 segments, the big one being the major segment, the small one being the minor one. So if we want to find the minor segment created by our chord AB, well, essentially all we've got to do is we get that sector that we just found and subtract that triangle. Some people like to put in a formula. So if we did, it would be a half r squared theta for the sector, and then for the triangle we could use our sine rule for the triangle. So half AB, but in this case A and B are both the radii, so half r squared sine theta, common factor there of half r squared theta minus sine theta. Yeah, some people like to remember that. Some people just remember, oh, all I got to do is take away the triangle from the sector and to do it that way. So let's sub in our one and look at this wonderful expression we get for area. Because of course we like exact values. 25 pi root 2 minus 100 over 8 root 2. Okay, so 11i, we get to play with sectors and arcs and segments and all sorts of things.